especially energy efficiency topics, but we are also developing tooling for research data management and research software best practices. And one of the topics that we are working on is also the citizen science activities, because citizen science activities are quite common in environmental sciences, especially if geoinformation is involved. So it enables citizens to take part in many different activities like mapping biodiversity, assessing water quality, and geospatial tools are really essential for that purpose. That enables people to go to the field and collect data. But moreover, it enables people to analyze the data, to reveal some relations, some connections that are available. This empowers the citizens to help generate meaningful insights, which can in fact help evidence-based decisions together with the researchers and the decision makers. And this enables, in fact, people to move on from data collectors into data analysts and real citizen scientists. So, but when we want a public to use geospatial software, usually we have the barrier because those people are non-experts, and basically that means they have limited exposure to geospatial information, but at the same time limited exposure to geospatial software. So one challenge that we have most of the time with these tools is, in fact, steep learning curves of technical user interfaces. And basically, case studies shows that more accessible interfaces can really facilitate involvement of public to citizen science activities, especially for underserved groups like elderly people or young students, secondary school or primary school students. So that's why intuitive and simple interfaces to GIS software can really lower the barrier. So free and open source software plays a lot of role, of course, in the geospatial domain. And the best known example in terms of the GIS software, I think, is the QGIS. And it's also famous in having a complex interface. That is, I think, maybe expected because it is designed for users who really need full control on GIS functionalities. And it is really growing in terms of capabilities it's having. And this sheer volume of tools, user interface elements, plugins, results new users, especially people who have non-technical backgrounds, to get lost in the interface. So that's why it is really important to have simplified and less overwhelming interfaces available, especially for citizen science activities. So QGIS provides some options for that purpose. So the user interface can be customized. So there are some settings which enables you to disable toolbars, widgets, and panels. You can also change the look and feel. And relatively recently, user profiles are also added, which enables users to create different profiles with different settings so that they can switch easily. But one feature that is missing in core QGIS is that user interface elements cannot be shuffled or regrouped, so you cannot create new things. For that purpose, we have some extensions available. The most famous one is the customized toolbar plugin. So this plugin enables you to create new toolbars, and you can put any tools that you want on these toolbars, which is really nice. But unfortunately, this plugin doesn't have a drop-down tools function, so you still have the same number of tools on the screen, so you cannot squeeze them into a single tool button, which can be dropped down. And it is not updated since 2019, but it has a lot of downloads, and I think it's a nice visibility. Another extension that's available, which unfortunately I got aware after the submission of the paper quite recently, is called QGIS Workbench. This is quite similar, so this enables you also to disable different items and create new toolbars. And interestingly, it is part of in fact, a larger initiative, which is called QGIS Project, that aims to improve and enrich the user experience of QGIS. So this is basically what we also aiming at. But it was also from 2019, and since 2019, there is no activity also for this initiative. And this one has much less number of downloads, interestingly, even if they do the same, almost similar thing. They are from the same era. And probably the reason is this one is a more clear name, so customized toolbars. Whereas QGIS, the workbench, is not very clear to end users what it does probably. So when we came to our effort, QGIS Light basically offers a simplified user interface designed for non-technical users. We are doing these simplifications that the extensions are doing, but we are also enabling additional modifications. More importantly, this drop-down functionality, which really enables us to have more intuitive user interface. And in addition to that, we are not only enabling people to do it, but we did a user needs assessment. We created some user stories, and based on these user stories, we also identified some technical design constraints, and we simplified the interface based on that. So that means people using the interface gets a simplified experience out of box. They don't need to do the customization themselves. So the first point was to define a target group. So our target group is people with non-technical background with limited geospatial data literacy. But we assume that they already received a basic training about the GIS concepts like raster vector data, map projections, fundamental cartographic principles, etc. And we assume that they have some basic understanding of the desktop applications as well. So we work with students, and we created user stories. Like as a user, I want QGIS to open with a clean and simple interface so that I can get started without feeling overwhelmed. Or as a user, I want to explore and use map layers in 2 dimensions, like a paper map, so that I can easily understand the spatial pattern. So we created 10 of such stories. Due to the time limitation, I cannot go all over them, but they are listed in the paper. Based on these user stories, we created some technical design constraints because the target group is non-technical people, the user stories are quite basic, and it's very difficult to convert them into implementation. So that's why we created a little bit more higher level technical constraints, like default to a minimal interface with only essential toolbars, support loading data locally, only 2D vector raster data, which are actually one-to-one corresponding to the user's stories. But at the same time, for example, additional ones like no support for direct connections to spatial databases, because we consider this as an advanced topic for citizen science activities. We created 14 such technical constraints, and they are all listed in the paper. So based on this, we identified the actions that are necessary to simplify the QGIS interface. And basically, those are focusing on simplification of the user interface, like removing most of the toolbars, removing the panels, and fixing them. So because even if it's a nice feature to be able to move toolbars and panels as you wish, that's not something very useful if you try to teach elderly people or young people. So it's much better to have fixed layout so that you can explain many things easily, and then once they learn, they can use the interface. So also we removed some additional advanced features like model builder, etc. For that purpose, basically we analyze all the components of QGIS. We check the menus, toolbars, panels, and processing algorithms. We identified the non-essential ones, and we also identified the alternative versions, and we grouped them as much as possible for simplification purposes. There we had 3 key aspects so for this elimination. The first one was elimination of multiple access points to the same functionality. So in QGIS, you can run something by clicking a tool button, selecting from menu, and going to the processing toolbox and selecting there as well. In case of QGIS Light, we removed everything except the toolbar. So we only have 2 toolbars. The second one is to eliminate identical or similar functionality. So in QGIS, in fact, there are many functionalities which are redundant. So we removed all these redundant features, considering the most simplest version that is available, which provides minimum viable functionality, which may sound a little bit different for technical users, because most of the time, if there are two functions that are available, you try to keep the most advanced one, because then you can have more flexibility. But in our case, we don't want advanced ones. On the contrary, simple ones. That's why we went for the simple. And the last thing was elimination of advanced tools and functionality. And for that purpose, instead of removing them completely, we just hide them so that people, if they get a little bit more familiar with the interface, can enable them at a later stage. So, and in order to provide core additional functionalities, we also added two well-known plugins. The first one is Data Plotly, which enables basically nice graphs to be generated directly in QGIS interface. And the second one is Quick Map Services to provide base maps to the users. So, and based on this criteria, we created the plugin. The plugin is available in the plugin repository, so it can be directly installable through QGIS. The source code is open. We also published it on Zenodo for long-term preservation, and thanks to FOSS4GE Europe conference, we have also now a paper linked to that. So how does it work? Let me very quickly show you. So once you install the plugin doesn't automatically change the interface. We just put a QGIS blank green logo to the toolbar and menu where you can toggle the interface. And once you click, the interface gets simplified. The system records everything before simplification so that you can revert it back to the same layout once you disable the extension. So how does it work? So basically, we have only two toolbars, a top toolbar and for core functionalities and a sidebar for editing. We have the layer sidebar, we have the overview and the basic mapping interface. We also simplified the status bar just to keep simple functions. So what do we have? We removed most of the data loading functionality. We just provide access to vector and raster layers and CSV files, which are quite common. If you open the dialog, you can also open online OGC services. That's also available. So the second one is the base maps. So through the extension, we provide access to all these background layers, which are really important for people. And it's also possible to create new layers. And in that case, we just simplified to geo package and shapefile. We combined all the functionality regarding zooming and panning, and they are all as a drop-down. The same is also true for selections. Normally, all these options are individual tools that are visible on the interface, so which takes a lot of space. In this case, it's really limited. We kept the measure functionality. Plotly integration is just embedded. And basically, all the functions around raster and vector processing are also converted into drop-down boxes, which are really easy to access. And once you enable editing, the editing toolbox, sidebar becomes accessible. So all these settings can be customized. So if you want to have your own version of QGIS Light, you just need to modify the configuration JSON file, which has sections for toolbars, algorithms, panels, data providers, and status bar. By indicating which one you want and where they should be located, you can have your own custom QGIS interface. So while doing this work, we also had some time to have a little bit more in-depth look at the QGIS user interface from user experience point of view. And we think that we identified some issues. And very briefly, I want to mention also these ones. The first, from non-technical users' point of view, because they may all be fine for technical users, but I think there are some issues for non-technical users. The first one is the terminology. So it's quite inconsistent. It's inconsistent between tools, but even in the same tool, the inconsistencies exist. So for example, if you want to create an enclosing circle, you can create, calculate, and compute it. And these are all the terms used in the same tool. Multiple algorithms are available to perform similar tasks for different geometries, and their difference is not very clear. And there is also little guidance about it. So if you want to transform lines into polygons, you can do this by saying convert geometry type, by using polygonize, or by using lines to polygons. So these are three different algorithms, and they do the same thing. Some algorithms, they serve similar or complementary purposes, but they offer different sets of features. For example, remove duplicates by attribute allows you to save the duplicate records in a file, which can be really quite handy. well as the remove duplicate geometries, which performs the same operation, but instead of geometries, by using geometries instead of attributes, lacks this feature, so for no reason. Some algorithms have very similar names but carry out their task differently. So, for example, we have fill no data, which uses interpolation to fill missing data cells, whereas we have fill no data cells, which use a constant value for that purpose. And these are two different tools. Some algorithms, they have identical names. So Hillshade, which is a native algorithm, and we have the GDAL version of it. And in fact, the GDAL version is a superset. So everything you can do in Hillshade, you can do in GDAL version. And basically, it is not clear why we have both of them in the interface. And basically, the terminology mixture is also available there. Some algorithms are primarily intended for basically for model builders. So, for example, drop fields. You can drop the fields very easily by using the attribute table, by using interface. And for non-technical users, there is no need for this kind of tools. And raster calculator is something very handy for non-technical users, in fact. And interestingly, some very basic operations like rounding the values is not available in raster calculator. So you have to use an algorithm for that purpose. We have also some algorithms that are available which works for a single feature or multiple features. And basically, the multiple ones can be used for single as well. So, and performance-wise, they are also identical. So it's not very clear why we have both of them. So we have these kind of issues. And the last thing that I want to highlight is, in fact, the help system. So in the online documentation, we have a lot of information that is available, but unfortunately, most of that information for all GDAL-related algorithms are not available in the embedded help system. So basically, GDAL algorithms doesn't have any information. And for some native algorithms, the information is also extremely basic, even if it's available in the documentation. And one critical another point is also the outputs that are generated by external files. So if you use the native plotting functionality, you get a plot as a PNG file, for example, which you need to click and open, and it is located in a temporary folder in an encrypted file name. So if you have a critical look, it might be really good to have a look at these existing user interface elements and try to streamline a refined and standardized user experience. So I think this can be really helpful for everyone. So as conclusions, so in citizen science activities, public most of the time contributes for data collection, but they unfortunately cannot take part most of the time in data analysis, so they cannot be citizen scientists. If we can lower the barrier, this might be possible. And we think that QGIS Light extension can really help to fill the gap and provide a simplified entry point for that purpose. During the study, we identified all these additional factors that hinder a better user experience, and we think that a community-driven approach for user interface and user experience research for QGIS can be really useful. And we hope that QGIS Light can serve as a first step for that purpose. In fact, there are some nice developments regarding to that. So quite recently, there is a QGIS enhancement proposal. I think that's coming from the authors of customized toolbars plugin, which aims to, in fact, bring that capability natively QGIS. And I just by chance also saw that there was another initiative about context switchable user interfaces or workspaces, which enables people to create different interfaces. And they are all after, actually, this is the second presentation that I had. The first one was a QGIS user conference last year where we introduced the first version of the plugin. And these developments are all after that. And we hope that maybe we initiated some discussions on that topic. There is some future work. So we want to simplify the installation. And we want to also bring this help functionalities into the system, and if possible, disable some advanced options that are available in the user interface. But for that, I think we need some time. But if you are interested, we will be very happy to work together. So please just reach out by email or LinkedIn, or we can also have a talk here. And we will be very happy to have your feedback. Thank you.